If you're a beginner in machine learning, you might be wondering why, in all the toy examples that you're looking at, they are using random forest or logistic regression when doing classification. You might have seen more powerful gradient boosted trees like YDFs, GPT, or XGBoost and wonder, why not use these models? In this video, I will show you how to use gradient boosted trees on small data sets because it shows the dangers of overfitting and the importance of regularization. Now, I'm not going to cover everything in detail. I've already written a Medium post that goes through all of this. And I also have an accompanying solution to the Titanic dataset competition from Kaggle, if you wish to look in detail how I solved it. The reason why they tend to use random forest or logistic regression is because these tend to guard against variance. That is, they guard against overfitting the model. And so they work well on small data sets. They also don't have a large number of tunable parameters. On the other hand, gradient boosted trees tend to guard against bias. And so with small data sets, they're prone to overfitting and they have a lot of tunable parameters. So in order to use something like gradient boosted trees, you will have to use a lot of more regularization. You can do this with cross-validation tied together with an efficient hyperparameter search. For example, a Bayesian hyperparameter search with the Optuna library using their tree-based or tree-structured Tarzan estimator, TPE. That will allow you to optimize accuracy in the case of the Kaggle competition, or a more appropriate metric for classification, if you wish. So with that, you have your answer. There are two more things I would like to clear up for beginners. Yes, random forest is an ensemble method, and yes, gradient boosted trees, XGBoost, is an ensemble method with random forest being bagging and gradient boosted trees being boosting. However, even after you do train these models and tune them, you can still do meta ensembles. For example, you can do a voting style classifier where you take, for example, XGBoost and YDS GPT model and have a combined vote or weighted vote between the two models on the output. You can also have a stacker where you train a meta classifier on the outputs of those two base learners. The last thing I'd like to cover is choosing the correct metric for your model. This is something beginners wonder about, and unfortunately, the Kaggle competition uses accuracy. Now, we could very easily think of a situation where we had 99% of one class and 1% of another class, and simply predict the majority class and achieve 99% accuracy. So what do you use to judge your classifier? Typically, you would use the area under the receiver operating curve, which plots the true positive rate versus the false positive rate at all thresholds. When the area under this curve reaches 1, you have a perfect classifier. When it's 0.5, you have no predictive value for your binary classifier. Now, this only measures the positive class. So when the values are skew, that is, your positive class and your negative class aren't balanced, you tend to get an overly optimistic measure of your classifier. So when you have something like the Titanic dataset, where those that did not survive outweigh those that did, you would want to use the precision recall area under the curve, which is very similar, except it's precision plotted against recall. Finally, I said that these are plotted at all thresholds. Your model also is going to serve a downstream purpose. So you should take a look at your confusion matrix and decide whether or not you're interested in precision, recall, specificity, or maybe a harmonic mean of precision and recall using the F1 score, and tune your threshold in order to maximize that value. And with that, you have a few quick tips for how to use more advanced tree-based models how to use hyperparameter tuning, ensembling, and the correct metric when evaluating classifiers. For more tips, follow me on X at Coffee First.